Alright, so in this lesson we're going to explore arrays and pointers in more detail, and you will begin to see how to use them in your programs. Like the last lesson, for the purpose of this lesson we are going to assume that all text characters are encoded as ASCII. In the previous lesson I showed you how to clearly visualize how variables are actually stored in memory. I also showed you that a variable really should be thought of as two different things: the location of that variable in memory and also the actual value of the variable. Also, I showed you that these two values are not at all the same. The location in memory is not the value. Now we are going to explore this further and learn about how to use the memory addresses where variables are stored in a practical way. This will introduce you to the concept of a pointer, which is a way to keep track of the address in memory of some data. We will talk about pointers more in future lessons. So let's again consider the string of text ABC123, and let's recall how it is actually stored in memory. So if you recall, this is how it looks once it's stored in memory. Now let's store the string of text ABC123 into our 16-byte RAM that we used in the previous lesson. First, let me go ahead and draw out the RAM. And here you go. I've went ahead and created our 16-byte RAM, each byte in RAM having its own unique address corresponding from 0 to 15. So how would we store the string of text ABC123 into the RAM? So when you have a string of text, remember that this string of text consists of multiple bytes. A memory address only corresponds to a single byte. So let's suppose our programming language looks at this string of text and decides it's going to store it at location 6 in memory. So that would be here. Now if we're going to store the string of text ABC123 at this location, notice it can't fit because this is only 1 byte. So what actually happens is that you're going to store only the letter A at this location, and then at the very next location you're going to store the B, then the C, then the 1, then the 2, and then the 3, and of course this last byte is going to be set to all zeros if it is not already set to zeros. So you're going to have A, B, C, 1, 2, 3, and then the terminating character. I want you to observe the following fact. Every single character in our string of text has its own memory address. Even though the string as a whole starts at one particular address, in this case 6, each character in the string occupies a different location in memory. In fact, you could say that the location 6 only corresponds to the A, or you could say that it corresponds to the entire string because that's where the string starts. Now, I want you to do a mental experiment. On your own, follow these steps. Start with the address of 8, which is 1000 in our 16-byte RAM. Say the character stored at that address, which in this case is going to be C, and then go to the very next address, say the character stored at this address, which is going to be 1, and repeat the process of saying characters until you reach an all 0 byte. By doing that, you have just simulated exactly how the printf function works. So let's go over this one more time from the very beginning. If we write printf ABC123 in memory, what we're going to have is somewhere in memory we're going to have the string of text ABC123 with the A, then the B, then the C, and then 1, 2, 3, and then the null termination character. So what printf is actually going to do is it's going to first of all locate the memory address of the first character, which in this case is here. Then it's going to print that character. Then after it's done printing that character, it's going to move down, print the next character, then it's going to print the next character, and it's going to keep on doing this until it reaches an all 0 byte. If any part of this lesson is unclear, feel free to ask questions.